Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back for some more R300 content. Kind of took a little break because I kind of got baffled for a little bit about what I was seeing when I was doing some testing. But then I finally figured out what was going on. And what's happening, or at least what I'm seeing, is an amplifier that's hypersensitive to the tubes that are installed in it. And I don't mean just that you can hear, subtle little audible differences, that some of them have horrible distortion and other ones sound fine, and you can swap the tubes from one channel to the other, or just the 6S and 7 from the left to the right channel, and the distortion changes, which it shouldn't be doing that. And I ran into this problem with another amplifier, but let me show you what I'm talking about. I ran through a series of tests, and like I said, it took me a few days to figure out this was even what was happening, because I was getting very inconsistent testing done between one session and the next. Like I would take the tubes out, I would do some work on the amp, and then I'd put it back together. It's like, what happened? And then, I'd do something that really shouldn't have had much of an impact, or I'd double check my work, put the tubes back in it, and get a totally different reading. So then I started moving the tubes around in the amp and was like, oh wow, here's what we got going on. So let me show you what's going on with this amp. Okay, so at this point, what we've done is we've done the modifications to the power supply, going to the two 5AR4s and moving a few wires around and adding 50 ohms of resistance. And this is also with a touch of extra negative feedback added. I tried removing the negative feedback. I tried more negative feedback, which started causing some issues. I had to go a pretty good bit more before I started seeing signs of the beginnings of oscillations. Didn't seem to like having any type of capacitance across the resistor. And so this seemed like a good point to leave the negative feedback at. Again, my amplifier has zero negative feedback, but it's got a very different schematic or circuit design, and it's also got different output transformers. And given these are potted in these big metal cans, we have no idea what they are or what's inside them. I'm beginning to think that they could be what we're seeing with the square waves and the frequency response. Not 100% sure, but kind of gave up on trying to get that to behave, and I'm just trying to get the THD and the frequency response in a reasonable place. So with some hand-selected tubes put in the right positions, I was able to nurse this result out of the amplifier. As you can see, the left and right channels are very even as far as distortion versus the power. And over the years, I've ended up with about a dozen of these 6H8C tubes that I could roll into this amp and get this result that we're seeing here. And this is also with the Shugi 300B-Z tubes. As you can see here at 1%, got just over 4 watts. Up here as it's crossing over 2%, we've got almost 7.5 watts. And 2% is kind of where I say that's the max power. If you get up here to 8 watts, which is what they claim the amp can make, we're at 2.3, 2.2%, which still isn't unreasonable. And like I said, you can see how evenly these two tubes are matched, or the whole amplifier is matched channel to channel. But this took some experimentation, rolling different tubes and swapping them left to right channel to get them to behave this way. So let's look at the THD plus noise. You may have remembered before it was off the scale down here on the low end, and then even up in this range it was pretty high, and it contributed a lot to the total THD plus noise when we looked in this range here, which is where the power is being made. So let's see what we've got this time. And you can see it starts out at 1% when it was off the scale before. And you can see after doing these changes to the power supply, here at 4 watts, where we were seeing 1% distortion, we're only seeing 1.2% with the THD plus noise. And so we drastically reduced the amount of noise that we're measuring in the amplifier with these two small changes of the power supply improvements and then the breath more negative feedback. And I can't show you this because I've already done the adjustments to the global negative feedback, but it really had very, very limited change on the noise profile that we were seeing or measuring. Most of that came from the power supply improvements. So let's switch back to the THD so we know we've got the noise under control. And I want to show you what happens when we change to another pair of 6H8C tubes, which should be identical. So this is the pair of 6H8C tubes that the amp came with. The ones that we were using in the previous test were out of a batch that I had acquired a couple years ago when I was playing around with these tubes, and honestly I think these tubes sound quite nice. You can definitely buy a lot worse sounding 6S7 tube than these 6H8C tubes sound. So here we go. Let's run the THD test on this pair of tubes. And as you can see, the left and right channel isn't perfectly matched, but these aren't drastically different. And as you can see here, when we get up in these higher power ranges, there is more distortion, especially on channel 2. There's about a 0.3% difference in distortion between the two channels. And as you can see here on this channel, we got 3 watts at 1% distortion compared to what we had earlier. And then on this channel, it's making 4.5 watts at 1% distortion. Same thing here up here at the upper limit at our 2% distortion, which we kind of called our high watermark. We got just over 6 watts, but then on this channel we've got right at 8 watts. So let's now try swapping the channels left to right with these two 6S and 7 tubes, or the 6H8Cs that we've got in this amp right now. And here we go with the left and right channels switched. And now look at the huge difference we have in the THD between the left and the right channels. And all we did was swap the same tubes from the left to the right channel. And as you can see here, there's almost a whole percentage point of difference in the distortion at 5 watts. Down here at 2 watts, there's a 0.5% distortion difference. But like I said, when we get up here in these higher power levels, there's almost a whole percentage point of difference between the two channels, and that's just from swapping the tubes left to right. So let's give a try of putting a different 6SL7 tube in. This next batch of tubes that we're going to be rolling into the amp are all tubes that I tried in the Willsenton R8, and they performed fine, and they actually sounded really good. So we're removing the Wilsonton 6SL7, and we're going to drop in a JAN Sylvania 6SL7 GT. Again, this was I thought, a really nice sounding tube in the R8. And I think you're going to see a pattern here shortly. I'm letting this warm up. That for some reason, this amp seems to be hypersensitive to the tubes that are installed in it. To get that original measurement that I showed you that does look really nice, and I'm sure sounds really good, I had to go through about 8 different tubes and play with swapping them left to right to get a final set that were evenly matched as far as THD and also had low distortion. Several of them looked like this red line up here that were just super high distortion, and I'd pull this tube out and stick another one in, and it would come down here to where this blue one is, and they're the exact same tubes. So let's see what this other 6SL7 does. And we're going to have one channel that goes past 1% distortion at 1 watt. Here we've got a whole percentage point of distortion different. At 3 watts we have 2% distortion, and then on the other channel we have 1% distortion. That's huge. And again, we are, best case at 2% distortion with this 6SL7 tube, we're making 5.5 watts. Where we were making 8 watts with the other 6SL7. And again, this tube worked fine when I put it in the Willsenton R8, and it didn't create this high distortion that we're seeing now in the R300. So now I'm going to drop another pair of 6S7 GTBs. These are some National Electronic made in USSR tubes that are likely new old stock tongue soles, and these tubes sound really good in the R8, and they also sound really good in my 300B amp, and they have pretty low distortion numbers. I mean, they're at least as good as these 6H8Cs, if not better. And let's see what they do. And then before we're done here, we're going to drop in the Willsenton 300B tubes. Maybe try to go back to the best front end tube setup and change to the Willsenton 300B tubes so you can see the impact that that has on the distortion levels. And here we go. And these are fairly close left and right channel. But again, one channel is going to go past 1% distortion at 1 watt. 2% distortion, we're making 4.5 watts still. This looks similar to those 6H8Cs, but now I want to swap them left and right channel and see if we have the same issue we had with those other 6S7 tubes. And these are warming up. You can see here, this has a little less than 0.5% of distortion difference between the left and the right channel. It's about 0.5% there. About the same there, maybe a little more, and they're never going to be perfectly the same. On most amps, there is a little bit of difference. If I see it, this kind of variance isn't a huge problem and is pretty normal. So let's see what it does now with these left and right channels swapped. And once again, we're seeing a wider gap between the left and the right channel just by swapping the tubes from the left to the right side. And I have to say, I doubt people are going to be able to sit down and swap these tubes left and right and be able to figure out where the best place to put the tubes is without some sort of software like this that can measure it. And you can see once again, we've got almost a whole % of distortion difference between the left and the right channel just from swapping the tubes from one channel to the other. It shouldn't make that much difference. If an amp calls for a 6S7 tube, it should produce similar distortion levels no matter where you put it in the amp. You shouldn't have to cherry pick the position that you put the tubes in to be able to get the amp to perform right. And I've run into this before with my 300B amp when I first was running it with the circuit design that I came up with, and it was caused by one of the 6S and 7 stages not being run hard enough, and it was causing different tubes to perform differently plugged into the same spot in the amp. And I think that's probably what's happening here, is one of the stages of the driver is being run too softly, and because there's not enough current running through the tube, it makes it hypersensitive to what tubes in what position in the amp and creates these sorts of problems. So let me see if I can find that setup that we started with, and I'll run it to show you again what it does with these 300B-Z tubes, and then we'll put the Wilsonton tubes in and I'll show you what they look like, and then we'll wrap up this video. Okay, we're back to the set of tubes that have this really nice looking curve, and as you can see, if you have the ability and a pile of tubes sitting around where you can swap them in and out and around and stuff until you find a set that will actually play nice together, this amp does make good numbers with the small modifications that I've made to it so far. But the problem is most people don't have, an audio analyzer suite and an analog discovery 2 to hook up to their amp and a dozen 6H8C tubes to roll through until they find a set that plays well together. But here we are at 1% distortion. It's making 4.5 watts, and at 2% distortion, it's making just over 7.5 watts, which is, those are really good numbers. But it's going to take a very special set of tubes to actually hit those numbers. So let me swap out these 300B tubes and reset the bias, and I'll show you what those look like. And this is with the 300B tubes biased right in the center of the meter. Okay, so got the Wilsonton 300B tubes put back in the amp and biased up. And let's see what the distortion profile looks like on these tubes. As we can see, left and right channels are almost exactly the same, just like they were before. And I did try swapping the 300B tubes when I first started running into this issue with the left and right channel not being the same, and found that swapping the output tubes made no difference. The distortion was not following the output tubes. So you can see here, we've got more distortion or less power at the same distortion level. And you can see here at 1% distortion, we're making 3.6 watts. And then right here at 2% distortion, it's making 6 watts. And it's probably where they start clipping because it starts skyrocketing. When you're at 8 watts, it's like 5%. So these Wilsonton tubes do have a little higher distortion, but you can see with the right tubes on the front end, they're capable of doing really low distortion numbers with these, limited mods that I've done, all the way up to, about 4 watts. And so they're not the problem. While the 300B-Z tubes have less distortion, the majority of the distortion changes that we're seeing have to do with the front end tubes and how they're configured. And so I've got more work to do. I need to figure out what's going on there, and this looks like a good place to wrap up this video. Well, as you can see, there's definitely something weird going on with this amp, and I know some of you guys are going to want to be jumping to Wilsonton's defense and say, oh, you've just got a bad sample. And guys, it's just not the case. I'm not trying to beat up on this brand, but it's getting frustrating seeing something that's this highly rated by so many other reviewers, and I'm seeing all these problems with them. And then, the manufacturer reaches out to me and is, they're concerned about what I'm saying, and I'm like, well, I'm just reporting what I'm finding. And this is another case of that. I'm not doing anything to make this happen, but it shouldn't be changing its performance when you move the tubes from one side of the amp to the other. Not like we're seeing here. I mean, maybe subtle differences, but not whole percents of distortion and watts of power changing by putting in a different brand of the same model tube. And like I said, I'm going to link the video below. I can show you where this was happening with my 300B amp when I first built it. And I got kind of frustrated with it and took a break for a while so I could just kind of think about it. And then I came back and started playing around with it, and I found the problem. That the cascode, or I guess the lower triode and the cascode, which is a pair of triodes stacked on top of each other, the lower one was biased wrong. And when I fixed that bias problem on the driver tube, I could put any 6S and 7 tube in the amp and get the exact same distortion readings. I could move them around in the amp and it didn't make any difference. And so I know that if you get tubes biased wrong, that it can make that tube super sensitive, and you could have the tube like right on the knee of falling off a cliff, and if it's just on one side of it, it's okay, and you get just on the other side of it and it like falls off this distortion cliff. And that's what we've got going on here. And I've got to figure out which tube or which triode is causing the problem. And I really think it's the first triode in the 6S and 7 that's direct coupled to the 6SL7. And what's happening when we change the 6SL7, it's slightly changing the bias point on that first triode of the 6SN7 because they're direct coupled, and it's making it do crazy stuff. And I'm not even sure that that first triode in the 6SN7 even needs to be used or even be in the amp. We might be better off just jumping past it to the final cathode follower triode that's feeding the 300B amp and just use the 6SL7 triode and then the cathode follower, and just let that other triode just sit there doing nothing. And I've run into that with the A12 amp when they were using both sides of the 12 AX7 when it sounded better just using one side. So anyway, I've got to dig into this. This is going to take some experimenting. I've never seen a layout like this, the way they've done the driver front end of this amp. And I'm a little frustrated because the manufacturer asked me not to share the schematic, and I feel like that if I could share this with the DIY community, that there's some people that are smarter than this stuff about me that could look at this and go, oh yeah, that's not how you should be doing that. And so I don't feel I should do that since they asked me not to share it. And I don't know why they don't want the schematic out there. This is such a weird front end. Nobody's going to ever copy this to build an amp out of it. And I can't see this giving it any kind of special sound because honestly it didn't sound as good as the simple design that I used for my amp that only has one driver tube per 300B. And so anyway, as you can tell, I'm probably kind of frustrated by this, also from being personally attacked for just insinuating that there may be something wrong with the design of the power supply. And as you saw, changing from those 274B tubes to some 5AR4s, moving a couple of wires around so that things were wired just a little differently, and adding a 50 ohm resistor, totally cleaned up all that noise that we were measuring on the noise plus THD test. And so I didn't do anything else to the amp that would have done that. And so clearly that was noise coming through the power supply. And maybe people think noise sounds good and they like the sound of that power supply buzz in the music. I don't know, because people are saying, oh, I got to have my 274B tubes because they're special. All I saw was that they added noise to the amp, and that's not what I want to hear. So sorry about the little bit of a rant. Like I said, I'm a little frustrated, and also just makes me question what I'm doing here if I've got just these hostile people going after me for questioning what these other reviewer guides have said about some product. And yeah, I'm not going to shut up, but it's still frustrating. So thank you all for your support. Going to try to get more work done on this soon. I'm going to show you that little bit of feedback that I added, tweak. It's a really easy, couple solder points to add a resistor there. I need to sit down and listen to the amp with this, kind of perfect storm tubes that are in it now, with some Mundorf aluminum oil caps put in it, and see if this sounds like it looks like in the measurements. If it sounds good, then we're going to try to figure out how to make it look like this on the analyzer with any tubes that you put in it. And if you guys are interested about doing your own testing, Audio Analyzer Suite, they just came out with the new Analog Discovery 2. I guess it's the Analog Discovery 3. They've got the 2s on sale. You can pick these up now for like $100, $150 less than what I paid for this, for the kit with the breakout board. Get the freeware software, and if you got a pile of tubes, you may be able to make one of these amps sound great without having to do any further work on it. But there is some underlying thing that is holding this amp back, and I'm going to figure out what it is. So again, if you're enjoying my channel, please subscribe. We're getting close to 9,000 subs. That will be awesome. I'd really like to hit 10K. That's kind of a point that I'm shooting for. Please like the video. Thanks to you Patreon folks and you other supporters. And until the next video, have a nice day.